We're now going to move on to the float type. So floats are a separate numeric type creating using digits with a decimal. So floats always have a decimal place with them, and they are a distinct type from integers. So they are not integers, they are numbers with decimals. So let's just take a number like 8.5. This is a float, and it doesn't matter how many decimal places it has, but it has this one dot which is treated as a decimal. So if I place this in the type function like this, type of 8.5, and I press shift enter, you will get returned the type float. Okay, so let's take a few more. So again, it doesn't matter if it's 0.12345, that is a float. You don't actually have to place numbers after the decimal place. So if we do 99 dot, this will actually be considered a float and not an integer because it has a dot. So you can be lazy. If you want a number to be a float, you don't have to put the dot 0 over there. You can just leave it as a dot like this. Now, something that's interesting is that you can use scientific notation to create floats in Python using the letters lowercase e or uppercase e. So for instance, if you want to write 1 million, you can do 1e6. So this is just saying 1 times 10 to the 6th. So this will be like, this just really means add 6 zeros to the end, or move the decimal place over by 6 places. And this will make 1 million. It's a little bit hard to see, but there are 3 zeros there and another 3 over there. You can do something like 5.27. You can do capital E and 12. So this will be equivalent to 5.27 trillion. So you can use either lowercase e or uppercase e. And if I press shift enter, it'll just expand it out. So there'll be 12 places over here. Most of them are zeros, but that's how you can do scientific notation with lowercase e or uppercase e. Just Python gives you another way to write it. Now, unlike integers, so integers in Python, you can actually make arbitrarily large, just as large as you want, or small, and talk about negative numbers, but negative integers are also possible. So with floats, you can't make a number too large. You're limited by the precision of your computer. So for instance, the easiest way to show this is, let's say I want to make a number with 308, or say 300 zeros. So 1 times 10 to the 300. So 1 followed by 300 zeros. And there's so many, it'll just display it like this. This is still a float. If you don't believe me, you can always put it into the type function, and you can verify that whatever this object has been produced, it is in fact a float. So 1e300 is, a float. But if I go to 310, now it says inf, which stands for infinity. So your computer just doesn't have the precision to hold numbers at a certain limit. So depending on your computer, how many bits, what the bit size is for a float, it's usually 64 bits. That's a little bit out of scope for this particular lesson. But what I wanted to show here is that you can't just store, a number that is larger than your computer's precision limit. All right, so just like with integers, you can use underscores for readability. So let's say we're doing a float that's 1,534,876.156. You can write it like this, so it helps clear things up. And that is a float. When you execute the cell, it'll just put it out without the underscores, but this is just for human readability. Again, you can insert underscores wherever you want, and every third place is good, so like that's essentially where the comma would normally go. All right, so that is the next type. We've learned about integers, booleans, and now we've come across floats, which are just digits with decimals in them.